lightning. Okay, so lightning phenomena. In this lightning phenomena, so lightning phenomena is a peak discharge. It is a peak discharge in which the charge accumulated in the cloud, positive and negative charges. This is called charge accumulated in the cloud, discharges into the neighboring cloud or to the ground. So like this. This is called charge inside the cloud, and also this is charge inside the cloud. Two clouds are uh, when coming to each other near. So then what happens means there is a peak discharge takes place in between the two clouds like this, cloud to cloud. This is called cloud. This is one cloud, and this is another cloud. There is a peak discharge in between these two. There is a spark. There is a lightning. It takes place in between these two clouds. This is called cloud to cloud. Peak discharge in between the cloud to cloud, and also discharge charges discharges into the ground in this way, cloud to ground. Okay, cloud to ground. Charge accumulated in the cloud is discharges into the neighbor cloud and also cloud to ground also. In this way, it is discharging, and also it is way in the discharging cloud to cloud. There is a lightning takes place in between two clouds. Otherwise, there is a lightning takes place in the cloud to ground and also cloud to air also. So charge accumulated in the cloud, it discharges into the neighboring cloud or ground or air. So in this way, this charge is accumulated. So how these charges are takes place in this clouds means we can understand by using different types of theories. Okay, lightning phenomenon is a peak discharge in which the charge accumulated in the in cloud the cloud discharges into the neighboring cloud. Okay, or cloud to cloud and cloud to air. Okay, the electrode separation that is called cloud to cloud or cloud to ground is very large. These two separation between these two clouds are very large, generally in the range of 10 kilometers. Okay, the mechanism of charge formation in clouds and the discharge is quite complicated and uncertain process. So in this, there are different types of theories based on this. We can understand this cloud discharge. Okay, lightning phenomena, and then charge formation in clouds. So how charges formed in the cloud we can understand by using different types of theories. Okay, first this is called introduction regarding the how charge formation in the clouds. First, during the thunderstorms, positive and negative charges are separated and heavy rain currents. Positive charges and negative charges are separated by heavy air rain currents. This is like positive charges and negative charges are separated in this way. Okay, during the thunderstorms, positive and negative charges are separated by heavy air rain currents like this. So this is called heavy air rain currents. Because of this, positive and negative charges are separated. So upper part of the cloud is positive charges, and lower part of the cloud is called negative charges. So because of heavy air currents, the positive and negative charges are separated. Okay, and here, so then upper part of the cloud is temperature is very less because of this ice crystals present in the upper part of the cloud. Upper part of the cloud is a positive charges, and also there is a ice crystals present in the upper part of the cloud, air in the lower part of the cloud. So this upper part of the cloud is positive charges and also ice crystals. Because of temperature is very less in upper part of the cloud, temperature is very less because of this ice crystals in the upper part of the cloud motion in this direction. So here there is a crystals, ice crystals here, and this negative here down lower part of the cloud is called rain. Okay, so ice crystals in the upper part of the cloud and rain in the lower part of the cloud. Okay, first positive charges in upper part of the cloud and rain in the lower part of the cloud, and also temperature is less in the upper part of the cloud. That's why ice crystals present, and temperature is less in the lower part of the cloud. Okay, so the charge separation is depends upon the height of the clouds. Understood? Charge separation is depends upon the height of the clouds. That is called positive and negative charges. Separation is depends upon the height of the cloud. If the height of the cloud is changes, the charge separation between the positive and uh, is changes. Inside of the cloud, the charge separation will be changes based on the height. So which ranges from 200 meters to 10 kilometers. with their charge centers distance about 25 250 meters to 2 kilometers, or 0.25 kilometers to 2 kilometers. Okay. The charge separation depends upon the height of the cloud, and which ranges from 200 meters to 10 kilometers, and the charge sensor distance about 25 to 50 meters to 2 kilometers. Okay, understood? So then the charge inside the cloud maybe has high as 1 coulomb to 100 coulombs. The charge inside the cloud 1 coulomb to 100 coulombs. This is the one of the points regarding to the charge formation in clouds. The charge separation depends upon the height of the cloud, and also the charge inside the cloud may be as 1 coulomb to 100 coulombs, and the positive charges is upper part of the cloud and negative charges in lower part of the cloud, and ice crystals present in the upper part of the cloud because of less temperature. So below minus 40 degrees Celsius, because of this ice crystals in the upper part of the cloud, and rain is the lower part of the cloud. And next, cloud may have high potential as 10 to the power of 7 to 10 to the power of 8 volts. Okay, cloud may have this type of high potential 10 to the power of 7 volts to the 10 to the power of 8 with field gradient ranging from 100 volts per centimeter to 10 kilovolts per centimeter. So this is the some cloud may have the high potential 10 to the power of 7 to 10 to the power of 8 with field gradient ranging from 100 volts per centimeter to 10 kilovolts per. This is the concept, okay, for charge formation in clouds. And then the energizers associated with cloud discharges may be very high. So, okay, and as charge formation in clouds like this, this is called one cloud. This is in this motion of the cloud, and this is called ground, and this is called field gradient. Field gradient versus ground, and this is the charges formation. Here, this is called upper part of the cloud, and this is called lower part cloud, and here positive charges and negative charges, and this is called local region. This is called local region. So cloud motion in this direction. So upper region positively charged, upper region is positive charged, lower region is negatively charged, and local region near base head positively charged. This is called local region, and this is upper region and lower region. Field gradient versus ground. So this is the field gradient. The direction of the field gradient from here positive charges to the ground. That means here there is maybe a possibility of accumulation of negative charges in this ground because of this positive to negative. Here positive to negative. Here this is called a lower part of the cloud is occupied by negative charges because of this field gradients from positive to negative. Here positive ground to cloud and ground to cloud in this direction. So here this positive charges and here negative charges in the lower part of the cloud. And then this is called local region is a some positive charges also takes place in the inside of the cloud. Then because of this, there is a field gradient present cloud and local region to like this in this direction. Okay, positive to negative and negative to positive in this direction. The cloud positive and negative charges are formed. And then theories based on charge separation in the clouds can understand by using different types of theories. Okay, charge separation in the clouds can be understood by using this Wilson theory of charge separation, Simpson theory of charge separation, Reynolds and Mawson's theory of charge separation. These are the three theories can be by using this can understand the charge formation in the clouds. Okay, first one Wilson theory of charge separation, and next Simpson theory, Reynolds and Mawson theory. So by using these theories, we can understand. So first one, Wilson theory is the assumption based. Wilson theory, according to this, charge formation in the clouds can understand by based on assumptions. So he is some taking these some considerations as assumptions. He can explain the how charges are formed in the cloud. It is based only on assumption and large number of ions present at atmosphere. So according to the Wilson's theory, large number of ions are present in the atmosphere, and many of these ions attach themselves to small dust particles and water particles. Many of these ions attach themselves to small dust particles and water particles. According to this theory, is assumption like this assumption. Okay, at normal electric field exists, that is called field gradient. A normal electric field exists in the atmosphere under fair weather conditions, which is generally directed downwards towards the earth. Okay, if the field exists, so like this, the field gradient present in the atmosphere between cloud and ground. Okay, so according to this Wilson's theory assumption, A normal electric field exists in the atmosphere under fair weather conditions, which is generally directed downwards toward the earth. Okay. And next, the intensity of the field is approximately 1 volts per centimeter. Intensity of the field is 1 volt per centimeter, 1 volt. Okay, the distance between the clouds is kilometers. That's why this voltage also changes, like the range of kilovolts. Okay, that's why the intensity of the field is approximately 1 volts per centimeter at the surface of the earth, and the decreases gradually height like this fashion. Okay, at 9,500 meters, it is 0.02 volts per centimeter. Next concept, according to the Wilson's theory, the relatively large raindrop like this, the relatively large raindrop, okay, approximately 0.0 centimeter radius, falling, this field becomes polarized. Like this, positive and negative charges, like this, it is a polarized as a positive and a negative charges inside of the raindrop. Relatively large raindrop, 0.5 centimeter diameter, centimeter radius, falling, this field becomes polarized. The upper side acquires a negative charge and the lower side is called positive charges. The upper side is acquires positive negative charges and lower side acquires positive charges according to this theory. Okay, this is called water drop. The electric field is present near the and around the raindrops like this fashion. So positive to negative, this is called negative charges. Upper part of the raindrop acquires negative charges because of this field is gradient like this fashion. Okay, and next, this is called positive charges. This is negative to. In this way, this is the field gradient present on the raindrops. This is called negative ions, and this is called electric field. Okay, so the relatively large raindrop of 0.1 centimeter of radius falling with this field becomes polarized. That is called positive and negative. The upper side is acquires negative charges and the lower side is acquires positive charges. So from the lower part of the drop attracts negative charges from the atmosphere. So lower part of the is called drop is called positive. That's why it's attracting negative charges from the ground. The negative ions, that is attracts negative ions from the ground. Because of this is a positive charge. So the lower part of the drop attracts negative charges from the atmosphere. Thus both positive and negative charges which were mixed up and are now separated like this fashion. Positive and negative charges are separated in this way. Okay, so charge separation in thunder cloud according to Wilson's theory. This is next, Simpson's theory. According to Simpson's theory, there are three different types of regions present, regions in the cloud. So that regions are called A, B, C. According to Simpson's theory, this cloud can be classified into three types of regions. First one is called A, B, C, like this, A region, B region, C region. So like this, three types of regions can be classified. This cloud, A, B, C. Okay, the below region A, air currents travel above 800 centimeters per second. In this below region A, this is the region below A. So air currents travel at a speed of 8,000 centimeter per second. This is the speed. Because of this speed, no raindrop fall through. Okay, and in region A, air velocity is high. Air velocity is high enough to break the falling raindrops, causing positive charges spray in the cloud and negative charges in the air. Okay, so because of this positive charges spray in the upper part of the cloud, negative charges in the lower part of the cloud. So negative charges are here only, but positive charges are spray into upper part of the cloud. So in this way, that's why the upper part of the cloud is like positive charges and lower part of the cloud is negative charges. Below region A, air currents travel 800 centimeter per second. Because of this, no drops fall through, and in region A, air velocity is high enough to break the falling through raindrops, causing positive charges spray in the cloud and upper part of the cloud, and negative charges in the air. Because of this heavy rain currents, the positive charges in the upper part of the cloud and negative charges in here only, negative lower part of the cloud. And this upper part of the cloud is temperature is very less because of the ice crystals present in this region. Okay, and the impact of air on these crystals make negatively charged the distribution of charge within the cloud ash. This is the negatively and positive charges distributed, and also temperature. Here 0 degrees Celsius temperature of the cloud below this region, B region or A region, at A region, the temperature is very less at 0 degrees Celsius. That's why here raindrops are present, and this and here upper part of the cloud temperature is will become very less. Maybe minus 20 degrees means less than minus 40 degrees for that minus 40 degrees condition. Means minus 50 degrees for ice crystals present in the upper part of the cloud. And this is called negative rain. This is called positively rain and air currents in this direction and cloud motion. Okay, so this is about Simpson's theory. According to this theory, there are three different regions are present on this way: A, B, C. Okay, ice crystals and temperature, and this is the essential. Next, Reynolds and Mawson's theory. According to this theory, we can understand this how charges are separated. So according to this theory, thunder clouds are developed at heights of 1 to 2 kilometers above the ground level. The thunder clouds are developed at heights of 1 to 2 kilometers above the ground level. Okay, they go up to 14 kilometers. The clouds they go up to 14 kilometers. This ground to cloud may be the distance of 1 to 2 kilometers, and is maybe they go up to 14 kilometers. Okay, the temperature is 0 degrees Celsius at 4 kilometers from the ground. The temperature at 4 kilometers is 0 degrees Celsius and may reach to minus 50 degrees Celsius at 12 kilometers. When the distance between the two cloud and ground is very high, that approximately 12 kilometers, the temperature is very less, minus 50 degrees Celsius. So minus 50 degrees Celsius means compulsory there is a ice crystals present in the cloud. So okay, at 4 kilometers distance, 1 to 2 kilometers or 4 kilometers distance, the temperature is very less, that is maybe 0 degrees Celsius, but up to 12 kilometers, the distance between the ground and cloud, minus 50 degrees Celsius, according to this theory, Reynolds and Mawson. Okay, then water droplets do not freeze at 0 degrees Celsius. That is why the rain drops present in the down part of the cloud, upper down lower part of the cloud. Water droplets do not freeze at 0 degrees Celsius. At 0 degrees Celsius, water drops this do not freeze, and freeze only when the temperature is below minus 40 degrees Celsius. That's why here the temperature is less than minus 40 degrees Celsius. So the freeze only when the temperature is below minus 40 degrees Celsius from solid particles on which the crystalline ice patterns develop and grow. So according to this theory, like this, ice crystal, how ice crystals present means, so the temperature is below minus 40 degrees Celsius from solid particles on which the crystalline ice patterns develop and grow. Okay. Next, thunder cloud consisting of super cooled water droplets moving upwards and large hailstones moving downwards. According to the Mawson's Reynolds theory, thunder cloud consisting of super cooled water droplets moving upwards and large hailstones moving downwards. So because of this, ice splinters should carry only positive charges. So that's why upper part of cloud, that is called H plus ions present in the upper part of the cloud. OH minus ions present in the lower part of the cloud. Because of this, there is a temperature changes. So water as H plus and OH minus ions, density depends upon the temperature. So lower portion has negative charges, negative charge density, that is called OH minus. Here, according to this theory, so this is called OH minus and this is called H plus ions. Okay, water has H plus and OH minus ions, density depends upon the temperature. So here temperature is very less, that's why H plus ions are present here and OH minus ions are present here according to this theory. Okay, lower part has negative charge density, OH minus, and upper part has net positive charge density. Because of this positive and negative charges having different temperature, because of this temperature, the ice crystals present. Okay. And next, this is about Reynolds and Mawson's theory of charges formation of clouds. Okay. Next, mechanism of lightning. Mechanism of lightning. Mechanism of lightning. So up to here, we are discussed about means how charges formation in the clouds. Then coming to the mechanism of lightning, how mechanisms. So there are three mechanisms, 3 or 4 mechanisms are present in the lightning. First one, pilot streamer formation mechanism. Pilot streamer formation. Second one, step leader formation. Then next third one, return streamer formation. Next dot leader formation. Like this, 4 different types of lightning mechanisms. Okay. So first one, pilot streamer formation of lightning. So this is called cloud. In this cloud, this upper part of the cloud is called positive charges and negative charges in the lower part of the cloud. So when cloud is coming to the near to the ground, there is a huge potential difference present in between cloud and the ground. Huge potential difference between this cloud and ground. Because of this, air will become ionized and there is a lightning takes place in between cloud and ground. So ground is a zero potential. It is not having any potential. No? There's a zero potential. So that's why it is a high potential. Cloud is having positive and negative charges. According to these theories, because of this, what happened means there is a high huge potential difference present in between two clouds. Because of this huge potential, the air will become ionized and the lightning takes place. So that lightning is called, first one is called pilot streamer formation. So pilot streamer formation, when the potential gradient is about to 10 kilovolts per centimeter. In this pilot streamer formation, the potential gradient is nothing but 10 kilovolts per centimeter in the cloud, and the air get ionized and lightning discharge gets started. So like this fashion, this lightning discharge gets started in this way. So when the potential gradient is about to 10 kilovolts per centimeter in the cloud, and the air get ionized and lightning discharge gets started. So in this way, so this streamer is known as pilot streamer. This is called pilot streamer. So negative charges in the cloud are uh, flowing like this in this like a pilot steamer. Through pilot steamer, the negative charges are going to the downside in this way. This steamer is known as pilot steamer. The pilot steamer is not visible. This current range is called approximately 100 amps of this pilot steamer. Okay, velocity of propagation 0.15 meter per microseconds, and velocity of propagation is 0.05 of velocity of light. Okay, so when the cloud, the distance between the cloud and ground is decreases because of this huge potential in the cloud and ground, the air get ionized and it will try to discharge through air like a streamer. That streamer, first the streamer is called pilot streamer. Okay, this is about pilot streamer formation. Next, coming to the step leader formation. Step leader formation like steps. Okay, step leader formation is called like tree branches. The streamer is formed like tree branches. This is called step leader formation. So step leader formation is depending on ionization state of air. Step leader formation is depends upon ionization of air. Is depending upon ionization of state of air. If air more gets ionized, then steps are formed like this. If the air more gets ionized, these steps are formed in this way. Okay, mechanism of lightning in this step leader formation. Step leader formation, this is called different types of steps like tree branches, like steps forms in the air because of this ionization of the air. If the air is more becomes ionized and this steamer like forms like steps. So that's why it is called step leader. So depending upon the ionization state of air, pilot steamer branched into several paths. That is, the pilot steamer is branched into several paths like tree branches is called as a step leader. Understood this step leader? So depending upon ionization state of air, pilot steamer branched into several paths. This pilot steamer path branched into several paths like tree. So this is called step leader, and it is a zigzag shape, and the length of the step approximately 50 meters. Length of step, this length of the step approximately 50 meters. Okay, and a series of steps are available in this lightning, and velocity of propagation 16.6 more than light. Velocity of propagation 16.6 more percent is more than light, and this process will continue until the stepped steamer strikes at ground. Okay, this process continues up to the pilot steamer strikes at the ground. So when it is pilot steamer strikes on the ground, these steps are disappear. Okay, only main pilot steamer present Okay. So this is the step leader formation lightning mechanism. And next coming to the return streamer formation. So this is called a return streamer formation. Whatever the positive charges in the ground that is written back into the cloud in this way, these positive charges is called a return streamer. The return streamer acquires charges, positive charges. In this cloud is called negative charges and your positive charges. And then, okay. Return streamer formation. So this is the concept regarding this. So soon after step streamer strikes at the ground, like this pilot streamer strikes at the ground. After this, what happens once soon after step-wood streamer strikes at the ground, okay, and follow the same path, return to the cloud. So the return streamer is having positive charges in this way. It's stepped back into the cloud, okay, and they follow the same path, whatever the path step-wood streamer strikes at the ground, the same path can be back into like this fashion. This is called return streamer. Okay. The streamer is known as a return streamer and its current range is called 1 kiloamps to 200 kiloamps. The current range is very, very high. That's why it is very dangerous. So velocity of propagation 10% of light and the negative charges of cloud getting neutralized. Here negative charges of the cloud here, negative charges, and this is called positive charges of the ground can be neutralized because of this huge current development between cloud and ground. Because of this current range is in the range of 1 kiloamps to 200 kiloamps. The negative charges of cloud is getting neutralized. At this instant gives lightning flash, which is visible. This instant gives lightning flash between the cloud and the ground, so it is visible. So but previous one it is not visible. What are this this is called pilot streamer is not visible, and but the return streamer formation is visible because of huge current. There is a lightning takes place in between the cloud and the ground. So velocity of propagation 10% of light and the negative charges of cloud getting neutralized, and then instant gives lightning flash which is visible, and less energy also known as cold lightning strokes. Return streamer is also known as cold lightning stroke and exists a few microseconds. It exists at a few microseconds. So this is about the return streamer formation. Then next coming to the dot leader formation. Dot leader. So the dot leader and this originate from another charge center. Is a dot leader is originate from another charge center. So from here, this is another charge center. This is called dot leader and a return streamer. So single branch uses the same path, whatever the lightning strikes at the ground, same path can here uses the same path and is actually the same single branch. But here previous these are the steps formed in the, like this. But in dot leader there is no steps of streamers. But here only one uh, streamer present, that is called only single branch. This is called dot leader. Okay, single branch, high current, and velocity of propagation is 3% of light. And next causes of more severe damages because of the returning dot leader. This there is a cause of severe damages, and it is having high energy. Also has hot lightning strokes. Previous one is called cold lightning stroke. Return streamer formation is known as cold lightning strokes, and your dot leader is called as a hot lightning strokes. So exist a few milliseconds, which is exist few microseconds is very less, but is exist few milliseconds. Because of this, it is visible. Okay, so dot leader formation is a originate from another charge center and uses the same path as a streamer, and high current, velocity of propagation is 3% of light and causes more severe damages. These are the some important concepts regarding to the mechanism of lightnings. Okay. So next coming to the lightning surges. Lightning surges are the surges that have high transient voltage. Lightning surges, because of lightning surges, high transient voltages, very, very less time. and the present the voltage, very huge voltage present in the transmission or power system, that is called lightning surges, are the surges that have high transient voltages, surge currents due to lightning sparks across arcs of isolation. Like this is the lightning. These devices, there are the different types of devices are there to protect this lightning surges. These devices defends the power system by diverting high voltage surges directly into the ground. So by using power system protecting devices, so the lightning can be diverting to the ground by using different types of mechanisms, uh, surges directly into the ground. And next definition, lightning is a phenomena. Is nothing but peak discharge into the charge accumulated in the cloud, neighboring cloud. I'm already explained this concept. Okay, lightning, how direct lightning strokes, indirect lightning strokes are present in the uh, between the cloud and the crown. Okay, direct lightning strokes. The lightning is a direct lightning stroke. So there is a indirect lightning strokes also present. Electromagnetically induced overvoltage due to lightning discharge taking place near the line is called stroke. So what is meant by lightning stroke is nothing but electromagnetically induced overvoltage due to lightning charge takes place near the line is called side stroke. Okay. Voltage is induced due to atmosphere changes along the length of the line, and also electrostatically induced voltages to presence charge cloud nearby. And this is the some concept. And next type of the strokes is called direct lightning strokes and indirect lightning strokes. There are two types of lightning strokes. First one is called direct lightning strokes, and second one indirect lightning strokes. This is called direct lightning strokes. The stroke, direct lightning stroke is present on the top of the transmission line, that is called shield wire, is called direct lightning stroke. This is the transmission line, and this is the cloud here, cloud to this transmission line, and the lightning takes place. This is called direct lightning stroke. And indirect lightning stroke is called when the lightning stroke is uh, like this indirect stroke. In this condition, this nearby transmission line is also affected, but that's called indirect lightning strokes, phase of conductor and shield wire. Neighboring transmission line is also affected the lightning effective because of this lightning is called indirect lightning strokes. Here, this lightning is falling on the transmission line directly. That is called direct, and the lightning falling on near the transmission line and to the ground is called indirect lightning strokes. Because of this, there is a changes in voltage levels of this transmission line and internal voltages. So what are the causes? How the internal voltages are developed means it may be due to switching or voltages of transient or voltage separation of high frequency, switching or voltages. Because of sudden switching operations, by adding the load or by removing the load suddenly, there is a switching or voltages takes place. That is, time is very less. Transient or voltage operations, voltage of high frequency, and a switch impulse or a switching surges. And next, switching over voltage. This is caused when the switching operations carried out under normal under conditions. Switching operations means to add the one biggest load into the grid or power grid. There is a switching of surges takes place. That is called switching over voltages. This is called when the switching operations, sudden adding the load or sudden removing the load into the grid or into the power system. That's switching over voltages are. And also because of the faults in the network, faults in the power system network, switching over voltage also take place. Any fault is occur, that circuit breaker isolate the healthy section from the faulty section. Because of this also, then switching operation, sudden removing the load. Okay. Also there is a switching over voltages. When an unloaded long line is charged due to Ferranti effect, you know what is the Ferranti effect? Receiving end voltage of the transmission line is greater than sending end voltage. Because of this also, there is a switching over voltages present in this. Okay. Switching, next switching impulse. So very less time the impulse voltage switching operations. That is because of this impulse, very high use voltage present in these transmission lines. So when the no load transmission line is suddenly switched on, voltage on line becomes twice the normalized normal system voltage. When the no load transmission line is suddenly switched on, because of this, a voltage line becomes twice the normal system voltage. So this is because of this switching operations. Twice the type of normal voltage present on the transmission line. This is called impulse voltage. This voltage is transient in nature. Okay. And next, coming to the switching phenomena for over voltage due to switching operations. So because of this energizing of a line or load rejection, that's energizing of a line is, so suddenly when source is connected to the transmission line, a power system, and also load rejection, suddenly load is removed, also causes this over voltages in the power system, causes damage to the power system operators, cannot withstand this high voltage. That's why maybe damages. Okay, because of this energies of line and load rejection, there is a cause of damage to the power system operators because of this very high over voltages. Okay, next, power system with voltage above 300 kV, switching surges are more prominent. If the power system is operating above 300 kilovolts, switching surges are more prominent. There is a huge effect on the power system operators if the transmission line is operating at 300 above 300 kilovolts. And next, surge resistors protect the operators from these high switching over voltages. Surge resistors, surge diverters, surge modifiers. These are the different types of arresters can be used to. So surge arresters protect the operators from these high switching voltages. Surge arresters, surge diverters, surge modifiers. These are the important devices, switching devices. Lightning arresters and surge arresters protect the operators from these high switching over voltages. Okay, not only surge drivers, surge arresters, surge modifiers, lightning arresters. They are different types of devices. Are that we will discuss that. Then power frequency over voltages in power system. Power frequency over voltages. So power frequency over voltages means sudden loss of loads. There is a power frequency over voltages, harmonic over voltages. The main cause of power frequency and harmonic voltages are, these are the concept. Sudden loss of loads. If the suddenly load is removed, there is a cause of over voltages, harmonic voltages, disconnection of inductive loads, connection of capacitive loads, disconnection of inductive loads, induction motors, disconnection of inductive loads, agriculture loads are nothing but inductive loads only. So by disconnecting the inductive loads, there is a cause of over voltages, harmonic voltages, and the connection of capacitive loads also. And this is also Ferranti effect, unsymmetrical faults, saturation in transformer, etc. These are the different types of causes of over voltages, harmonic over voltages, power frequency over voltages in power system. Okay, next, over voltages due to switching surges. First one, de-energizing of transmission line, cables, shunt, capacitors, banks, etc. Next one, disconnection of unloaded transformers, reactors. Next, energization of reclosing lines and reactive loads. And next, sudden switching of loads and short circuits and resonance, ferro resonance. These are the different types of origin of switching surges. So these are the different types of causes of origin of switching surges. Next, coming to the switching over voltages, that is called extra high voltages, ultra high voltage systems. Switching over voltages are extra high voltages or ultra high voltages in system, power system, because of these reasons. First one, over voltages are generated in extra high voltage systems when there is a sudden releasing of internal energy stored. So in the transmission line, there is an inductance effect because of this inductance. Energy stored in the inductor is suddenly released, that is called magnetic field. And also there is a capacitance between the transmission line and the ground, because that is called electrostatic effect. So capacitance effect and inductance effect. So because of this, there is a over voltage generated in extra high voltage system. So transmission is having some inductance and also capacitance. Inductance means electromagnetic field, and capacitance is like electrostatic field. Because of these two energy, there is a over voltage is generated in the extra high voltage system. And then different situations under this happens are: first one, interruption of low inductive currents. Next one, interruption of small capacitive currents and ferro resonance. So this is about switching over voltages in extra high voltage and ultra voltage system. Next one, what are the methods for protection of against lightning? Methods of protection against lightning. There are three different types here. So first one, overhead earth wire and lightning arresters or surge diverters, rod gap arresters or horn gap arresters. These are the different types of lightning protection against lightning. Okay, so these are the different types of devices. These are mainly three main methods generally used for protection of against lightning: overhead earthwire, lightning arresters or surge diverters, rod gap arresters, and horn gap arresters. Then one by one, first one, protection against protection from over voltages. So the current in the substation is about 10 to 20 kiloamps. So the current in a substation is about 10 kiloamps to 20 kiloamps. Because of impedance involved in the circuit, such arresters bypass these currents and protect the operators from lightning surges. So the surges, what is the important of surge arresters? Means whatever the current because of lightning that can be bypassed. Okay, surge arresters, whatever the surge present in the line that can be bypassed by using this surge arresters. Surge arresters bypass the high currents. Okay, bypass these high currents and protect the operator from lightning surges. Because of these transformers, electrical operators cannot withstand the voltage high current. That's why it is required to bypass the this high use current, bypass these high currents. Okay, surge arrestor is an important equipment from the point of view of protection. So surge arrestor is an important equipment from the viewpoint of protection. Protection point of view, surge arrestor is one of the important in power system. In HV operators, from the voltages over voltages caused due to lightning and switching phenomena. Because of lightning and switching phenomena, this over voltage is present in the transmission line. So that can be diverted by using surge arresters, bypass the use current. Because of lightning and switching phenomena, use current present in the system. So that can be bypassed because of by bypassing this, then only we can protect our electrical operators. Cannot withstand the use current. That's why protection is required. The bypassing of current is also required. Okay. And next, this is called, so one simple concept, by using this, we can understand the equipment to be protected. Here, what this is called transformer bushings or transmission line insulators. So this can be protected by using lightning arrestor. This is called lightning arrestor. And this is called nonlinear resistor. And here there is a spark gap. Lightning arrestor is placed in near to the equipment to be protected, and it is having resistor. That resistor is called nonlinear resistor. Under normal operating condition, the resistance of the this is very high. That's why there is no current flowing in this direction. Only this electrical transmission, electrical operators can work. The resistance will high under normal operating condition. Under any fault, any lightning, any surges under condition, the resistance will become less and the use current is bypassing to this lightning arrestor. Understood? So what is the nonlinear resistor? The resistance is not fixed. Under normal operating condition, resistance is very high because of there is no spark is takes place in between, and then this can be protected. In normal operating condition, there is no effect of in this electrical apparatus. Under lightning condition or switching condition, then use current bypass to the lightning arrestor. So this because of resistance is less. Under fault condition or lightning condition or switching operation condition, resistance is less, and then spark is takes place here, then discharge use current into the ground. So this is called lightning arrestor. So under normal operation, the lightning arrestor of the line, it conducts no current to the earth gap, is called non-conducting. Under normal operating condition, no conductor. So because of high resistance, and then on the occurrence of over voltages, so under over voltage condition, the air insulation across the gap breaks down. The air insulation across the spark gap can break down, and arc is formed and providing a low resistance path for the surge to the ground. Surge to the and ground, low resistance present. In this way, this excessive charge on the line due to the surge is harmlessly conducted through the arrestor to the ground instead of being sent back over the line. Okay, understood? So during normal operating condition, the resistance is high, and also this like open switch is not conducting. Under faulty condition, it acts as a under lightning condition or switching condition. There is a spark appear in between these two. Because of this, resistance become less and then discharging into the ground. So this is called lightning arrestor. So under normal operating condition, the lightning arrestor is placed in near to the So this is called lightning arrestor, and this is called operating principle of lightning arrestor. So this is lightning arrestor to protect the transformer from this lightnings, and also switching charges. The lightning arrestor space here. Okay, and jumper wire and bushings. These are the bushings of transformer. The bushings of transformer, we have to place the lightning arrestor. This is called transformer. This is called one pole of transmission line, and like this place. Any lightning or any surges are placed here, then use current diverted to the ground through a lightning arresters. Okay, and next the power circuit spark gap and lightning arrestor, and this voltage and current characteristics. And the next types of lightning arresters. There are several types of lightning arresters in the general use. Okay, the differ only the constructional difference. Constructional point of view, these lightning arresters are different, but operating point principle is same. They are differ only the constructional details, but operate on the same principle, providing low resistance path for the surges to the ground. Okay, and here, so these are the different types of lightning arresters. Valve type arresters, overhead earth wire arresters, overhead earth wire, valve type, and rod gap, and multiple gap, and horn gap, and expulsion tap. So these are the different types of operating devices for protection of lightning. Okay, so that means operating principle of the each device is same: rod gap, multiple gap, horn gap, whatever it may be. So operating principle is same, but voltage design, construction design is different. Constructional details differ only constructional details, but operating principle is same. So operate on the same principle, providing low resistance path during surges to the ground. Under abnormal condition, under lightning or switching operation or surging operation, surge operation condition, there is a providing low resistance path to the ground, and then the use current will be discharged into the ground. That is the principle of operation. Under normal operating condition, it acts as a high resistance. Under abnormal conditions, the lightning switching conditions, it acts as a low resistance, and then bypass the use current to the ground. And then these are the different types of lightning arresters. Next, coming to the overhead earth wire. This is called overhead earth wire. So phase conductors and grounding cables. This topmost conductor is called overhead ground wire, and it is provide the protection against lightning. So earth wire on a transmission line, this is called earth wire. Okay. The next rod gap arresters. So this is rod gap arrestor. This is called rod gap. Okay, there is a gap present in between upper part of upper insulation and lower insulation. Okay, to protect this insulator, transformer bushing, this is called transformer bushing, can be protected by using the rod gap. Under normal operating condition, it acts as a open switch, and there is no discharge in between. The spark is in between the rod gap, this gap. But during fault lightning conditions, there is a huge spark is discharging into the ground through like this fashion. Okay, rod gap arrest. So this is called rod gap. We have to maintain this. The rod connected to the line. The rod is connected to the line upper insulation, and the rod connected to the earth. This rod is connected to the earth. The upper rod is connected to the line, and this lower rod is connected to the ground or earth, and this is a gap. So this is called rod gap. So when this lightning takes place or switching takes place, use voltage appear across this. So at that condition, this spark is appear in between this gap and then discharge into the ground. This is called rod gap arresters. Next, horn gap arresters. So horn gap arrestor, here this two operator to be protected. Here we have to connect operators is connected into the our electrical operators means our transformer or any type of equipments we have to connect here through a choke coil and a gap, horn gap. So this gap is changes like this 1, 2, 3 positions. The gap is increased in between these two. This is called resistor. This can be protected, this choke coil. So two operators to be protected. This is, and then secondary side of this horn gap is connected to the ground, and this primary side, one side of this horn gap is connected to the transmission line at electrical to be operated protected. This is called choke. So practically, this looks like in this way, horn gap arresters and to arrest the lightning. So we know this choke coil having at a power frequency level that is called 50 Hz, XL is equal to omega L, that is proportional to the frequency, normal operating frequency. So, okay, and reactance will be less. Okay, it consisting of horn-shaped metal rods A and B separated by small gap A and B. Metal shapes, horn-shaped metal rods A and B like this. A and B are separated. It consisting of metal horn-shaped metal rods A and B separated in small gap. This gap is increases 1 at 1, 2 at 3. Distance changes between A and B, and this gap is also increases like this. A here at 1, the distance between these two rods is very less, and here medium, and here very high distance between these two, high distance at 3 different positions, 1, 2, 3. This separating the gap is very less. Horns are so constructed that the distance between them gradually increases towards the top. Gradually, distance between these two gradually increases, okay, towards the top. And then horns are mounted on porcelain insulator, like this. Porcelain insulator, this is any type of insulator is connected like this. And one end of the horn is connected to the line, one end of the horn is connected to the line, and another end is connected to the resistance and choke coil, and while another end is effectively grounded. So another end is one arm is connected to the through a resistor and choke coil, and to the electrical apparatus, and another ground is connected to the ground like this. Okay, effectively grounded to the another ground. Next, normally supply voltage is insufficient to normal supply voltage is insufficient to initiate the arc between the gaps. Normal supply voltage under a normal operating condition is insufficient to spark here takes place. Insufficient voltage to cause this spark here in this between. Normal supply voltage is insufficient to initiate the arc in between the gap. Okay, and the occurrence of an over voltages, spark over takes place across the small gap G, and arc is stuck. And occurrence of over voltages, spark over voltage takes place on this gap G, and arc is stuck. Okay, and then heated air around the arc, and magnetic field effect of the cause the arc travel up the gap. The arc moves progressively into positions 1, 2, 3 like this. The arc is moving progressively 1, 2, 3 like this. The distance is increases, and the arc is disappear. Okay, so at some position, the arc 3, position 3, distance may be too great for the voltage maintain the arc. Consequently, the arc is extinguished. So because of this higher distance at point 3 position, the arc is extinguished. Okay, the excess charge on the line, thus the conducted through the arrested to the ground. This is the about operating principle of okay, and then the resistance of R helps to the limiting the flow of current. The small value of resistance limiting the flow of current. Okay, and the choke coil is so designed that offers small reactance at normal operating frequency. XL is proportional to the reactance is proportional to the frequency. At normal frequency, reactance will be small. Okay, but very high free reactance at transient condition. Thus, the choke doesn't allow the transients to the enter into the apparatus to be protected. Understand? So under high transient condition, frequency is high. Frequency means high means reactance is high. That's why it does not allow the transient. Under normal operating condition, reactance is very small, and it can allow current. Okay. The gap between the horns are so adjusted that normal supply voltage is not enough cause the across the gap. Okay. This is about horn type arresters, and next to valve type arresters. Valve type arresters. So this is the valve type arresters, lightning arresters. So top of most of the line is connected to the transmission line and line connection, and the next side is connected to the ground. This is called spark gaps. This is called spark gap, and this is called nonlinear low resistance. This is called nonlinear low resistance, nonlinear resistance, low resistance series resistors. This is called series resistance, nonlinear resistance. This is called nonlinear resistance, high series resistance. High resistance series. This is nonlinear resistance, low resistance, high resistance. Porcelain or Pyrex glass housing. So like this, Construction is different, but working principle is same. So when the lightning or switching operations takes place on transmission line, then that gap will become spark and discharges into the ground. So any lightning, it allows the lightning and does not allow under normal operating conditions. Any under fault condition or a lightning condition or switching conditions, it can allow the spark into the ground this way. So this is about 2 valve type arrestors.